Lesson 22, or 27, or whatever it is trig functions of acute angles and the unit circle. Okay, so we're going to start out with some basic things. So we're starting out with Sohcahtoa. So when you guys learned Sohcahtoa, you learned that sine was equal to the opposite over hypotenuse. So go ahead and fill these in. So sine is going to be the opposite over hypotenuse. Cosine is going to be the adjacent over hypotenuse. And tangent is going to be the opposite over the adjacent. But there are three more. So you probably haven't seen these three others. I should probably show you guys this in Algebra 2, but I don't. Okay, so when we have cosecant, cosecant is the reciprocal of sine. I know that's confusing. Everybody wants it to be the c's go together and the s's go together. There's a reason why cosecant is the reciprocal of sine. All right, so if I have 1 over sine, that means it's 1 over the opposite over hypotenuse. Do I want to write all that out, though? 1 divided by a fraction? No. If it's the reciprocal of something, we can just flip that fraction over. So what is it going to be? Instead of opposite over hypotenuse, we're going to have hypotenuse over opposite. And secant is the reciprocal of cosine. So it's going to be hypotenuse over adjacent. And then cotangent is going to be the reciprocal of tangent. So it's going to be adjacent over opposite, exactly. So I always remember that the c's and s's go together, but that is a little confusing because cotangent is also a c. So you got to think cosecant and secant, those pair up with cosine and sine. But it's kind of the opposite of what you would think it is. Like it's not cosecant and cosine, right? It's cosecant and sine are reciprocals. So it's a little tricky for students to remember. All right, so it says evaluate the 6 trigonometric ratios. So whenever it says evaluate the 6 trigonometric ratios, that means that we want to find, oops, let me put sine first. I want to find sine, cosine, tangent, and then their reciprocals. So cosecant, secant, and cotangent. And it uses the word ratios, so it's okay to have fractions. We're going to leave them as fractions. So when I see sine of angle A, here's where my angle A is. I want to do opposite over hypotenuse. What fraction do I have in the end? 4/5. Do we all see that? Do I need to write out opposite over hypotenuse, 4 over 5? Do you guys get it? And cosine of angle A, well, that's adjacent over hypotenuse, so this is going to be the adjacent one now. That's the only thing people get confused on in geometry. They're like, which one's adjacent? There's two that are next to it. One of them's always hypotenuse, right? So call the one hypotenuse, the other one's adjacent. So cosine is going to be adjacent over hypotenuse. So 3 over 5. And tangent is going to be opposite over adjacent. So 4 over 3. So then the other three are just those reciprocals. So if we write them in this order, see how sine and cosecant are going to match up? Those are reciprocals. So instead of having opposite over hypotenuse, we have hypotenuse over opposite, which ends up being 5 over 4. So it's the reciprocal of this one. Right? And the next one's going to be what number? 5 over 3. And then the last one's going to be 3 over 4, exactly. So it doesn't take too long to write all 6 of them. All right, so it says use a calculator in degree mode. Do you guys know what that means for degree mode? The most frustrating part of pre-calc. You are going to have to go back and forth between degrees and radians a lot, depending on if you want degrees for your answer or you want radians for your answer. So we're going to hit mode, and we're going to go over to degrees. Do you guys see that on your calculator? So mode, highlight degrees, and then do second quit to get out of there. So we want to find the 6 trig ratios of 15 degrees. Okay, so I want to find sine of 15 degrees, cosine of 15 degrees, tangent of 15 degrees. And let's round to, let's do 4 decimals this time. Let's change things up. So when you do sine of 15, so check with me, you get 0.2588. Did you guys all get that? Okay. So then we do cosine of 15. So we get 0.9659. And then tangent of 15, 0.2679. And then all these other ones. Okay, so I definitely want you to do these with me because a lot of people do something on their calculator wrong. So get your calculators out. Okay, so I just told you a little bit ago that like x to the negative 1 is the reciprocal of things, right? Cosine to the negative 1 is not the same as 1 over cosine. It doesn't work that way. Okay, so if I have cosine to the negative 1, it's not the same. Okay, you know what they're using? Do you guys remember when we found f of x and then we found its inverse function? That's what it is. Okay, it's the inverse operation. So with logs, like natural log and e to the x were inverses, right? Okay, things like that. Okay, so if you see cosine to the negative 1, it is not 1 over cosine. So if I want to put in cosecant of 15, I have to do 1 over sine of 15 degrees. Okay, now you could get your answer for sine of 15. So go ahead and do that. We can do sine of 15. And then you can hit the button that says x to the negative 1. That's okay. That will do 1 over that answer. In which case you'll get 3.864. Well, I'll do 4 decimals, didn't I? I'll be consistent. 8637. Okay, did we all get that? Or you can do 1 divided by sine of 15. So everybody try inverse sine of 15. Do you know what I mean by that? So try this on your calculator, the sine to the negative 1 of 15. Did we get the same thing? It doesn't work. It yells at us, doesn't it? It says error, domain. Doesn't work. Okay, there's a reason that doesn't work. Okay. So what an inverse sine does is it finds the angle for a certain, so it finds like the theta when we have a ratio like 3 and 4 here, or 4 and 3 like I have above. So if I wanted to find what this angle was, then I would write it out and I'd be like, oh, sine of theta is going to be opposite over hypotenuse like this. So if I wanted to find what this angle was, that's when I do inverse sine. Do you guys remember that from geometry and algebra 2? Okay, that's what an inverse sine is. It finds an angle. And it won't work if the number is more than 1. Like if I try to take the inverse sine of 15, that number is more than 1. Does anybody remember why that doesn't work? Think about how sine is defined. It's opposite over hypotenuse. Can I have like 15 over 1? No. Why? Yeah, the hypotenuse is the biggest, right? Not saying hypotenuse is biggest, right? Does this make sense? Do you guys get it? So you can't have like a number that's more than 1 when you have a sine answer. So all of these answers like sine and cosine answers, these numbers will always be smaller than 1. Their reciprocals will be bigger than 1. Okay? All right, so secant of 15. So I would do cosine of 15. And then I would do 1 divided by that answer. So you should get 1.0353. Did you guys get that? And then cotangent of 15, so tangent of 15, and then 1 divided by that answer. So I should get 3.7321. Okay, everybody have those? Okay, we have that straight. We're not going to do inverse sine or inverse cosine if I'm trying to do like one of these reciprocals, right? All right, so 30, 60, 90 triangle. So we previewed this the week before Thanksgiving. I don't know how much you guys remember. We'll see. So think about your we'll use ends. So if I have 60 degrees here and 30 degrees here, I'm going to put n as my smallest side. Do you guys remember what the other two sides would be in relation to n? Yeah, so 2n. Which one, the top or the bottom? Yeah, the hypotenuse. And then n root 3. Yeah, because there's 3 different angles, 30, 60, 90, remember? Does that make sense? All right, so the next one. So if I do 45, 45, 90, I do n and n as my small sides. And n root 2. Good. You guys did remember. I'm so proud. Did all of you remember? You're like, no. All right, so it says use the special right triangles to evaluate the 6 trig ratios of 30, 45, and 60. So if I'm trying to find like the sine of 30 degrees, so the sine of 30 degrees, it would be the opposite over the hypotenuse, right? I'll draw it on the other page in a second. So the opposite would be n. The hypotenuse would be 2n. What do I get when I reduce those out? 1/2, exactly. So to make this really simple on us, I'm going to go ahead and I'm going to do 30, 60, 90 here. But I'm going to make the hypotenuse, well, it doesn't matter. Let's make this 1, this 2, and this root 3.
Can't you just like plug in 30, like sin 30 and then put that?
You could, but the downfall with that, if you try to do like sine of 30, your calculator does give you 1/2, but try sine of 60. It gives you 0.866 something, right? Do you guys know what number that is? No, I mean it's a decimal there, but we can write that as with a square root. So we want to know the exact answers on these. Because, you know, we're building things. We want to be precise. If you're building my bridges, right, you've seen that PowerPoint. We want them to match up. All right, so sine of 30 degrees was 1/2. The cosine of 30 degrees was what? So that would be adjacent over hypotenuse. What do we get? Root 3 over 2. Do you guys see it? I left off the ends. You can put the ends if you want. And tangent is going to be opposite over adjacent. So opposite over adjacent is going to be 1n over n root 3. Do you want me to leave off the ends? Does that bother you? So it's going to be 1 divided by root 3. Do we leave it like that? Rationalize, what do we get? Yeah, root 3 over 3. Do you guys understand that? 1 over root 3. If I multiply by root 3 over root 3, I get root 3 divided by 3. All right, now we're ready for the reciprocals. So what's the reciprocal of 1/2? 2. What's the reciprocal of root 3 over 2? 2 over root 3, which is 2 root 3 over 3, right? And then cotangent is the reciprocal of, let's use this one. Let's use the 1 over root 3. That's why I left it there. Flip it. Root 3. We like that one. All right, good so far? All right, how about the other ones? 45. That's using another triangle. So instead of putting the ends in, I could. This could be n, and n root 2. Since we know the ends are going to reduce out anyway, let's just put 1s. So I'm going to do 1, 1, and root 2. Okay, so what is sine of 45? It's opposite over hypotenuse. 1 over root 2, which is root 2 over root 2. Root 2 over 2. Cosine, also 1 over root 2. It doesn't matter which 45 you're picking. Let's say we pick that one. Opposite over hypotenuse and adjacent over hypotenuse are both 1 over root 2. So it's root 2 over 2. So what's tangent? 1. It's 1 over 1, right? Which is 1. Cosecant is the reciprocal of 1 over root 2. So root 2. Secant is also root 2. And cotangent is 1. All right, now for the 60s. So if I have 60 degrees, my opposite over hypotenuse is root 3 over 2. Okay, and you guys did a little like thing with your tables that involved like cosine and sine. Do you guys remember that cosine and sine have a relationship? Cosine of 30 degrees is the same as sine of 60. Do you guys remember that?
Oh my gosh.
The complementary angles. Do we see why that's true? Because when I did cosine, or when I did sine of 30, let's say, sine of 30 is opposite over hypotenuse. Cosine of 60 is adjacent over hypotenuse. Do you guys see how we're using the same numbers? Does that make sense why we would do that? Okay. All right, so what is the cosine of 60 then? 1/2. And then tangent of theta ends up being opposite over adjacent, so root 3. Did you guys get that? Cosecant ends up being the reciprocal of root 3 over 2, which was 2 over root 3, or 2 root 3 over 3. Secant was 2, and then cotangent was 1 over root 3, which is root 3 over 3. So you can go through that same process. Does this make sense? All right, let's pause here so you guys can have your break. we're going to do is we're going to like solve a triangle. So whenever you see the instructions that say like solve a triangle, what that means is we're going to find all of the angles and all of the side lengths. Do you guys remember this from Algebra 2 geometry? Okay. So we're just going to do a quick example of this, and then we're going to kind of move on. So it says in order to do this, we use two main theorems from geometry. So the triangle sum theorem, you all know this. The angles of a triangle add up to be 180, exactly. So we have A, B, and C. The measure of A plus the measure of angle B plus the measure of angle C equals 180. And the Pythagorean theorem, which says what? What if I drew it like this, though, and I put, does that work? No. So be careful with that. I always say with Pythagorean theorem, a squared plus b squared equals c squared when c is the hypotenuse. You guys know that, though, right? All right, so in order to solve the triangle, we either need to have two side lengths or we need to have a side length and an angle measurement. Catherine, put that away, please. So solving the right triangle. So if I have 50 and I have 10 and I want to solve this entire triangle, that means I want to find r, t, s, little r, little t, little s. We're finding 6 different things. Okay. If I was teaching geometry, I would make my students write it like this. Measure of angle r, measure of angle t. But in pre-calc, if it's a capital letter, I'm going to assume that you guys know that that's an angle measurement, right? Okay, so capital R is 50. Capital T is 90. It's a 90-degree angle. So what's capital S?
80.
40. How'd you get 80? Oh, man. All right. It's okay. It's morning. All right, so then we have little r. So do you remember little r is the one that's across from big R? Okay, so if I'm finding that, then I would need to use Sohcahtoa. And I can use Sohcahtoa because I have a 90-degree angle. So I'm going to do opposite over adjacent. So tangent of 50 equals r over 10. So I take my tangent of 50, and then I multiply by 10. And we'll round to 3 decimals if it doesn't say. So we're going to do 11.918. And we had little s was 10, so now I need to find little t. So I can do 2 different things here. I could do Pythagorean theorem to get it. I would just make sure you have that number in your calculator already, the 11.918 number. Like store it and square it, right? Or just do answer squared or whatever. Or I can do another trig ratio. And most of the time, I choose the trig ratio. I think it's less steps to actually do that. Okay, so I would pick the numbers that we've already, that were already there in the problem. I would pick the 10 instead of using the number that we've rounded. Okay, so if I want 10 and t and 50 degrees, and again, we use like 50 degrees just in case we make a mistake on the other angle, right? So we use the 50 just in case we messed up. So if I use my 50 degrees and I have adjacent and hypotenuse now. So set it up, it would be cosine of 50 equals adjacent over hypotenuse. Okay, and everybody try to solve that. Make sure you know how to do this. There's a reason I'm a broken record as a teacher, because I see these mistakes all the time. Did you guys get an answer? Does your answer make sense? Okay, it should be 15.557. If you didn't get 15.557, check to see what you did on your calculator. So here's what I did. It's like I multiplied the t over, kind of like cross multiplication if you want to think about it that way, like an over 1. So it's like we cross multiply. So we have t times cosine of 50, and then we divide by the cosine of 50. So I'm going to have 10 divided by cosine of 50. Does that make sense? Did everybody get that? Okay. So there's a reason I go through this, because people mess it up. So if you're getting something that's like people will always do like cosine of 50 over 10 or something. They'll get like 0.06. That's not that side length, clearly, right? It's t, it's the hypotenuse. It has to be bigger than 10. All right, so do we understand all that? So if I'm solving the right triangle on this one, then I have a, b, c, and I have little a, little b, little c. So again, we know some of it. We know that angle c is 90 degrees. We know little b is 12, and little a is 5. Okay, so then we find all the missing things. So let's say I want to find angle A. In this case, I would set up an equation, Neil. So I'd say tangent of angle A equals opposite over adjacent. right? Do you guys all see that? And this is where you use your inverse tangent. So on your calculator, you do that tangent to the negative 1 at 5 over 12, and we get A is equal to 22.620. Okay, so then we can find B by doing 180 minus 90 minus that 22 number. Or you could just do 90 minus, right, if you already knew one of them was 90. So 67.380. Is this making sense? Yeah.
So you just do tan to the negative 1 and then put 5
over 12. Yeah, so you can do it all together, like inverse tangent of 5 over 12. Yeah.
Do you use the inverse when you're trying to find an IC angle?
Yep,
and use the
exactly.
regular when you're trying to
Yeah,
find
because
an
it's kind of like I was saying earlier, it's kind of like natural log and E. They undo each other, right? So if I wanted to undo this tangent, I do inverse tangent in front, and then it gets rid of that. Okay, so it's like A equals inverse tangent of 5 over 12. So you can think of it that way. And then if you do the Pythagorean theorem, if you do 5 squared plus 12 squared equals C squared, you end up getting C is equal to 13. That's a Pythagorean triple that we use quite a bit. Okay, does it make sense? Okay, so we're moving on from that. So angle of elevation, angle of depression. So angle of elevation is when you're standing and you're looking up at something, like a building. This is an angle of elevation. Angle of depression is when you are standing on top of a building or something and you're looking down, kind of morbid. Maybe don't stand on top of a building and angle of depression. Okay, so this is angle of depression. Okay. So if you think about it, this angle right here ends up being the same as the angle of elevation. They're exactly the same. Do you guys remember why, using a geometry word, why those are the same? See this little Z shape that's formed? Do you guys know what type of angles those are? They're what? No? No, it's like the parallel lines that are transversal. You guys don't remember any of these? So these are corresponding,
I remember these.
right? Those ones weren't corresponding that I just drew. So what are the ones that make a Z shape? A Z shape here and here. You guys never talked about like the Z shape or anything?
No, it definitely did. That makes sense. That was summers ago.
Okay, the word alternate means opposite sides of the transversal. They're on opposite sides of the line that cuts through them. So alternate, and are they inside or outside of the parallel lines? They're inside, so they're alternate interior angles. So angle of depression and angle of elevation are alternate interior angles. That's why they're the same. So if you are standing on the top and looking down, or if you're standing at the bottom and looking up, those angles are the same. So it says the angle of elevation from a point on the street to a top of the building is 53 degrees. The building is 60 feet high. How far from the point on the street are you to the top of the building? So we'll call that x. So we just set it up. So we have our angle, and then do we have opposite, adjacent, or hypotenuse? Well, we have opposite, and we need adjacent, right? So we do tangent of 53 degrees equals opposite over adjacent. So if I'm solving for x, I would multiply my x over, and then I divide by tangent of 53. That's what I was saying earlier that people will mess up on. So we do 60 divided by tangent of 53, and we get 45.213. This would be in feet. Okay. So we're going back to our unit circle. Don't say, oh no, this is going to be your best friend eventually. There's magic in the unit circle. You doubt it? Oh, you doubt my magic. I'm a magician. I know the unit circle. All right. So now consider the unit circle. So again, the unit circle has this equation, x squared plus y squared equals 1. Okay. So do you see the connection? So let's talk about these numbers. Okay. So we said if we had like a 45, 45, 90 triangle, And you guys remember how I did 1, 1, and root 2 like this? What was the cosine of 45 degrees? It was the adjacent over hypotenuse, right? So it was going to be the 1 over root 2, which made root 2 over 2. The sine of 45 degrees was the same thing. What if I have a 30, 60, 91? Why did I draw exactly the same as the 45? And kind of make it a little taller. Okay, so that's 60 and this is 30. What if I have 1 across from the 30, root 3 here, and 2 here? What was the cosine of, let's do 30 degrees first. So cosine of 30 degrees, so here's 30. Adjacent over hypotenuse, right? So it's root 3 over 2. Okay. So I told you guys when we had the unit circle that we would draw in these like triangles. It comes from a bunch of triangles. Here's our triangle, right here. There's one of them. That's a 30, 60, 90 triangle. Okay, it opens up 30 degrees. And this is 60 here, and this is 90. Look at these two values here, root 3 over 2, comma 1/2. One of those is the sine value, one of them is the cosine value for 30 degrees. We're using the angle where we're opening. Remember how we talked about when we're opening angles? This is 30 degrees here, right? Coterminal angles, all of those angles we did before. So if I have 30 degrees, which one's the sine, which one's the cosine? What comes first? Root 3 over 2. Is that sine or cosine? It's cosine, right? So cosine of 30 degrees is the same as the x-coordinate of this point, okay? And sine of 30 degrees is the 1/2, okay? All right, so do I have a picture where I'm drawing all this out? So maybe we'll pause and we'll draw these on an actual unit circle. So I want you guys to think about them a little bit. All right, so when we talk about this unit circle, all of these points that we just did on the unit circle, so we just paused and did all those points, all of these points are cosine and sine values, okay? The x-coordinate, so the x-coordinate is our cosine of the angle, the y-coordinate is the sine of the angle. And you can check, you could do your little Sohcahtoa and figure it out, but every single one of those works. So it says, let theta be an angle measure and x comma y be a point on the unit circle corresponding. So we're on the unit circle. In other words, we have a 1 for our hypotenuse, right? So if I want to talk about like sine of theta, and I have a certain theta here, whatever point I have here, x comma y, the first one is my cosine of theta, and the second one is my sine of theta. I always tell people it's alphabetical order. Cosine comes before sine alphabetically, x comes before y alphabetically, okay? So sine of theta, if I have x here and y here, and it's the unit circle, I have 1. Do you guys see that sine of theta is equal to y over 1? Did you get it? Opposite over hypotenuse. Y over 1. So it's just the y value, which is what I just told you. And then the cosine of theta, well, that's adjacent over hypotenuse. So adjacent over hypotenuse is the x, right? That's why the x value is the cosine of theta. Tangent ends up being opposite over adjacent. It's the y over x. In other words, tangent is the same as sine divided by cosine. Right? It's the y value divided by the x value. Cosecant. Cosecant is the reciprocal of sine, so it's 1 over y. Secant is 1 over x, and cotangent is x over y. So cotangent, if I was writing it with cosines and sines, cosine over sine. Can you guys keep that straight? All right, so you're going to be doing lots and lots and lots of these. So it says evaluate the 6 trig functions of each real number. So basically what you're going to do is you're going to quickly like draw like a little unit circle, and you're going to be like, oh, I'm right here. We're going to do this little unit circle for every single one, and we're going to off to the side write its point. The point at pi over 4 is something comma something. What's the something comma something? What numbers do we have on the unit circle? Try not to look at it. Root 2 over 2 comma root 2 over 2, exactly. So the sine and the cosine, so remember cosine is the x, sine is the y. So the sine of pi over 4 is going to be root 2 over 2. What's this number? The cosine of pi over 4 is going to be root 2 over 2. I know they're the same number in this case. The tangent is the y divided by the x. It ends up being root 2 over 2 divided by root 2 over 2. What do we get? 1. Cosecant is 1 over root 2 over 2. Do you guys remember what 1 divided by root 2 over 2 was? It ends up being root 2. Because root 2 over 2 is really 1 over root 2. We just rationalized it. Do you want me to show you the step to do that? 1 divided by root 2 over 2 is 1 times 2 over root 2. And then 2 over root 2, you can rationalize. This becomes 2, which cancels with that. So you get root 2. I know, it's a lot. The sneaky way, here's a sneaky way. 2 is really root 2 times root 2. So when I divide by root 2, they cancel. All right, that's a sneakier way. All right, or you could just remember that the reciprocal of root 2 over 2 is root 2. All right, so secant is going to be root 2, and then cotangent is 1. Are you jamming to the music? Yeah. It's really obnoxious all day long. French. Sine of theta is 30 degrees. I like them too.
I don't have to.
I told him that you can hear the blinds open in this classroom. So hearing it through the wall is a lot. All right, sine of 30 degrees is what? So what point is this? So that's what we do. We always draw out the little unit circle. We draw the little radian measure. So not radian measure, the little ray, I guess. So we get what? We go over a lot, up a little. Do you guys remember that? So it's root 3 over 2, comma, 1/2. Should say 1/2 there. So what's the sine? What's the cosine? Sine is the y value. So we get 1/2. Cosine is the x value, root 3 over 2. Tangent is the sine divided by cosine. It's root 3 over 3, actually, because the 2's will cancel. You could multiply by 2, or you can flip it, do the fraction divided by another fraction. So we have 1 over root 3, which ends up being root 3 over 3. Cosecant is 2. Secant is the reciprocal of cosine, 2 over root 3, which is the same as 2 root 3 over 3. And cotangent is root 3. Do these make sense? You get it? Is that the last one? Some more? All right, you guys try these ones. So I want you to draw it out. So if you have 0 degrees, that's over here. That's the point 1, 0. I want you to think about them. So try 3 and 4 because you're going to have a lot of these to do on your homework, so you got to think about them. All right, so sine, did you guys get 0? Cosine is 1. Tangent is 0 over 1, which is 0. That one works. But on the reciprocals, 1 over 0, undefined. 1 over 1 is 1. 1 over 0 is also undefined, right? So some of those are undefined. 5 pi over 3. Think about where that is on the unit circle. It's almost a 2 pi. Oops. I do that all the time. Remove that.
Like, is it always written where the reciprocal of cosine is the first one?
Uh-huh. Oh, you want me to, like, what if I mess it up and I write them backwards?
No, it's just like it makes more sense if like the reciprocal.
No, this is the reciprocal of sine, sorry. Is that what you're saying? These are the reciprocals of each other. So sine and cosecant go together. The C's and S's. I know, it's weird. All right. Okay, so then 5 pi over 3, that ends up being 60 degrees away from 360, right? Think about it. Pi over 3, if I add that to 5 pi over 3, don't I get 6 pi over 3? That's 2 pi. Here's where I'm going to draw it. So that's where you're going to be able to draw those right away. You're going to know that those are there, okay? So this meant that I went over 1/2 and I went down root 3 over 2. So my sine is negative root 3 over 2. My cosine is 1/2. My tangent is sine over cosine. So if I have negative root 3 over 2 divided by 1/2, any guesses as to what that is? It's negative root 3. Do you guys see that? I can go through that whole process where I flip the second one and do times 2 over 1 and they cancel. Or you can just remember that if you have over 2 over 2, those will go away. Right? You can, it's like multiplying by 2 over 2. So I get negative root 3. All right, so then the reciprocals. So I have negative 2 over root 3, which is negative 2 root 3 over 3. I have secant, which is the reciprocal cosine, so 1 over 2, its reciprocal is 2. And then cotangent is negative 1 over root 3, which ends up being negative root 3 over 3.
If it's a reciprocal, does it go from negative to positive?
No. Okay, and then find sine, cosine, and tangent for the following angles. So again, if you can draw it out and you can say, okay, well, pi's over here, so that's the point negative 1 comma 0. So then the sine of pi, cosine of pi, and tangent of pi are what numbers? So sine is 0, cosine is negative 1, tangent is 0 over negative 1, which is 0. Does this make sense? So something like negative pi over 6. Where's negative pi over 6? What quadrant? The fourth. And it's just down just a little smidge, just like 30 degrees down, right? So I always kind of exaggerate. I just draw it really close to that axis. So then I can say, oh, it's the big number first and then the small number second. So it's root 3 over 2 comma negative 1/2. So the sine of negative pi over 6, oops, I did negative pi over 2. The sine of negative pi over 6 is negative 1/2. The cosine of negative pi over 6 is root 3 over 2. And the tangent of negative pi over 6 is negative 1/2 over negative root 3 over 2, which becomes negative, when you rationalize, negative root 3 over 3. Oh, 3's are hard to draw there. You could work it out, but it works out to be that. Okay, are we feeling pretty okay with this stuff? So let's kind of flip through. So these are the ones that I'll ask a lot, where I don't ask you to find every single one, because I think that's kind of annoying to be like, find sine, cosine, tangent, cosecant, secant, and cotangent. That's a lot. Okay, so a lot of times I'll just say find one thing. So what I want you guys to do on this, because we're trying to get used to the circle, is I want you to draw the circle for every single one. So when you say sine of pi over 6 is 30 degrees, it will be really close to that x-axis. So just kind of draw it up just a little smidge, so you can say, oh, that's a big x value and a small y value. So what's the sine of pi over 6 then? It's 1/2, right? It's right there, so it's equal to 1/2. If you just want to circle, that's fine. Cosine of 3 pi over 2, do you guys remember where 3 pi over 2 is? It's down at the bottom at 270 degrees, right? That's the point 0 comma negative 1. So what's the cosine value? 0, exactly. Does this make sense? How about cosine of pi over 4? That's at 45 degrees. So what's it equal to? Root 2 over 2, because they're both root 2 over 2, right? All right, and then you can go through with that process. So we'll do some more of these next time.